the Airborne Observatory, a new multi-scale remote sensing facility. We would like to acknowledge our interdisciplinary co-investigative team for their inputs and ideas. Many others inside and outside the university have also contributed to the concept, and we know this team will grow.
100 years ago, the Canadian National Topographic System was established, and airborne remote sensing in Canada literally took off. Iconic planes like the Vickers Vedette carried cameras and operators to produce maps, supply remote communities, and monitor for natural disasters. Growing sovereignty concerns at the outset of the Cold War led to a surge in mapping missions, and by 1948, 85% of Canada's territory had been mapped from the air. Today, many mapping needs are met with drone and satellite imagery, though there are still gaps in the spatial and temporal sampling domains where airborne surveys are still needed. Research-based missions tend to be in one of two general areas of need. The first is for specialized, high-resolution, multidimensional landscape-scale data that cannot easily be provided by drone or orbital platforms. And the second is for time-critical questions, where airborne missions remove distance or cloud cover constraints to examine events like wildfires and landslides, or under dynamic environmental conditions like changing snow depth, soil moisture, or leaf flush as droughts progress.
Airborne remote sensing is crucial for hazard modeling and disaster assessment, environmental monitoring, resource inventory, community planning, and other research needs. Within our team, we are researching the causes, processes, and effects of water and forest-based climate hazards and natural resources. These include wildfire, tornado, drought, flooding, and other climate-mediated landscape changes across Canada. For example, here is a tree fall direction model from the Northern Tornadoes Project that employed both time-critical and specialized collection of attributes using airborne imaging. Core barriers to our research are 1. A need for time-critical landscape scale data. 2. The high cost can be prohibitive. 3. Mobilizing time-critical missions can be almost impossible. And 4. The availability of integrated image data are rare.
Our goal, therefore, is to enable time-critical advanced airborne remote sensing for interdisciplinary science and graduate training. We aim to do this by creating an airborne observatory at London Airport with a twin-engine survey plane equipped with laser ranging, hyperspectral and thermal imaging systems. This rapid response, versatile and adaptable platform will address key questions within 4 major domains. The first is our core research area, and this emphasizes climate resilience needs, where we'll focus on natural disaster process and hazard modeling, as well as mitigation solutions. The second is natural resources, where the focus will be on multi-scale data fusion for geological, vegetation and water resource mapping. The third, remote surveillance, think sovereignty here, where high-resolution data will calibrate new satellite products. And the fourth, economic development, where public and private sector partnerships will enable innovative and new services.
The survey aircraft is at the heart of the proposed facility, but it is the addition of remote sensing instruments to measure surface properties of 3-dimensional size and shape, reflectance and temperature that allow us to answer the questions about changing landscape attributes of terrain, vegetation, and infrastructure. The capital budget for this proposal will be around $10 million. Chris and I joined Western in January with the goal of building the facility, following 26 years of hands-on experience in the field. We both regularly led remote sensing missions with our graduate degrees, me as a system operator in a research lab, and Chris as an international airborne field manager with industry.
In 2002, as PhD and postdoctoral trainees at Queen's University, Laura and I set up the Canadian Consortium for LiDAR Environmental Applications Research. By 2012, CCLAIR had supported hundreds of researchers and a wide range of mission objectives, including the first LiDAR survey of Western University's campus in 2006. From 2004 to 11, and again from 2016 to 2025, I established and directed 2 airborne remote sensing labs in Nova Scotia and Alberta.
Our pioneering work in this field has been recognized through commendations in the Nova Scotia Legislature, National Society Awards, and in TV documentaries and news reports. Working with centers, institutes, and other collaborators, we will create 3 levels of access. Priority will go to Western labs and time-critical needs, followed by outside network of community partners, then industry partners pursuing commercial goals. Financial sustainability will be ensured by supporting diverse needs across priority levels and by being adaptable to changing needs and funding opportunities, thus ensuring a sustainable business model.
Presently, no such facility exists in Canada. A few universities do have airborne research and development partnerships with industry, but none provides the interdisciplinary, rapid response, versatile, and adaptable solution needed to address specialized, time-critical research needs. If we build this unique airborne observatory, it will establish Western as the leader in Canada's strategically important field of airborne remote sensing research and development. Thank you.